In this video, we're going to look at problems which involve the intersections of two sets in a Venn diagram. So in this diagram, we have set A, we have set B. We can see that there is some intersection between the two of them. And what we're going to try and determine is what is the number of elements in set A or set B. So if you recall from the previous video, when we want set A or set B, we want the number of elements that are within both of these sets. So that includes the overlap. Well, let's just try and tackle this logically. If we want all of the elements in set A or set B, the area that I shaded in red is the number of elements that are in set A. Well, similarly in blue, I could shade the number of elements that are in set B. Now, this gives us A and B, but you can see that we've overcounted this portion that is in the center. So we counted it once for set A, and we counted it once for set B. So since it's been counted twice, we need to subtract what that intersection is. Well, what is the intersection? This is the number of elements that is in set A and set B. So here is our formula that we can use in order to determine the number of elements in set A or B when we have an intersection of sets, as we do in this diagram. So it's the number of elements in set A plus the number of elements in set B minus the number of elements in set A and set B. Okay, let's see how we can use that to solve a problem. So in this problem, we have a group of 40 students. 26 are enrolled in mathematics. 10 are enrolled in computer science. 9 students are taking neither course. So part A, how many students are taking both mathematics and computer science? And part B, how many students are enrolled in mathematics only? Well, a quick observation. If we add these numbers together, 26, 10, and 9, we end up with 45. That is more than the number of students that we have selected. Well, how can this be the case? It's because we have some students who are enrolled in both courses, both mathematics and computer science. So let's take a look at how we can fill in this Venn diagram and then use that to assist us in this problem. So we have the universal set, which is the entire diagram, including students who are not enrolled in mathematics or computer science. And from our original problem, there are 9 students who are in neither of these sets. We're going to name these sets. I'm going to name the one on the left M for students taking mathematics, and the one on the right C for students who are taking computer science. Okay, how many students are taking mathematics or computer science? Well, we had 40 students in total who we are interested in. And we can see that 9 of these students are not enrolled in either one of those courses. So 31 students have to be enrolled in either mathematics or computer science. So that means when we add up the numbers in each of these 3 regions, they are going to have to add up to give us 31. All right. We derived this formula, and I'm going to rewrite it slightly, just so it matches up with how we named the sets in this question. So the number of students taking mathematics or computer science is equal to the number of students taking mathematics plus the number of students taking computer science minus the number of students taking mathematics and computer science. What do we know? Well, we know that there are 31 students who are taking mathematics or computer science. So this number is going to be 31. In the original problem, we are told that there are 26 students who are taking mathematics, and there are 10 students who are enrolled in computer science. So we have 26 students enrolled in mathematics, we have 10 students enrolled in computer science, and we have some unknown number of students who are enrolled in mathematics and computer science. And I'm just going to use a variable for that. I will use x. So in grouping these terms, we have 31 equals 36 minus x, and we can see pretty easily that x is going to be equal to 5. That tells us we have 5 students who are taking both mathematics and computer science. Okay, so this was part A. Part B asked us how many students are enrolled in mathematics only. So let's use our answer from part A to assist us. So we have 5 students who are taking both courses. From the original problem, we have 26 students who are enrolled in mathematics. So how many are enrolled in mathematics only? Well, let's use our proper notation. We want the number of students who are enrolled in mathematics but not enrolled in computer science. So this would be the number of students in set M minus the number of students in set C. So we have 26 students who should be in this set in total. Subtract the 5 students who are in both sets, and that gives us 21 students. So we have 21 students who are only enrolled in mathematics. Although it was not asked in this question, we could also find the number of students who are only enrolled in computer science. The notation would look like this, and it would be the 10 students who are enrolled in computer science, subtract the 5 students who are in both sets, and that would give us an answer of 5. And this is also a good way for us to now check the solution. Our universal set should have 40 students in it. Well, we have 21 students taking mathematics only. We have 5 students taking computer science only. We have 5 students enrolled in both. And we have 9 students who are taking neither. If we add all of those numbers up, so 21 plus 5 plus 5 plus 9, that gives us 40, which is also the number of people who were in the universal set. Okay, so there is an overview of a formula that we can use to assist us, and how to find some information about intersecting Venn diagrams.